Okay, looks like we're at 1:30. Can you all hear me? Okay, cool. So maybe, well, who am I? I'm John Billings. I've been working at Yelp for almost 5 years, and during this time I've done a bunch of work on our service-oriented architecture, so splitting out our monolith into a bunch of different services. And I've done a lot of advising different teams how to do this. And so Swagger has formed an important part of this process. So, just a little bit about Yelp. What we do is we connect people with great local businesses, and some statistics. As of the end of Q3 2015, we had about 89 million unique monthly visitors via mobile, and more than 90 million reviews contributed since the beginning of the company. And about 71% of all searches now come from mobile, both web and app. And we're present in 32 countries. So, HTTP JSON is amazing. There's a unicorn, a very happy unicorn. There's so much supporting infrastructure. If you're in Java land, then there are frameworks like DropWizard. Or if you are in Python land, so I'm familiar with Python, Java, there's HTTPlib, there's simple JSON for doing JSON decoding, you've got frameworks like Pyramid, and then at the infrastructure level, you've got things like Varnish to do your HTTP caching, you've got HA proxy and Nginx to do your load balancing, and both of those have good layer 7 support for doing nice things with HTTP. And you've got Apache for actually serving up things. And then for debugging, you can use things like curl and JQ. So this is great. So much support. But if you look carefully, the unicorn's actually crying. Why is this? Why is the unicorn so sad when everything is so great? Well, here is a mythical situation that has never happened to any of us. Right? So the website is down again. Why is that? Oh, I just pushed the pet store service. So the pet resource, it takes a string, right? Like I pass it a string. No, it's an integer, right? So there's confusion over this API. You know, curse you and your strings. So if only there were a better way to specify our API. So we do actually have a few options. I'm going to walk through some of them. So you can write specification documents. And here's an example of a spec doc for the pet store service. And just in case you don't know, the pet store service is an example CRUD web app where you can kind of post new pets, you can search for pets, you can kind of download pet information. And so this could be an endpoint for the pet store app. And you see there are some attributes and some required or optional, and some descriptions over what each one of those means. And then there's a response, so an array of pet objects defined below. So, pros and cons. So it's really easy to get started with this. And this is what we did at the beginning when we were breaking out our services. And if you use something like Google Docs, with commenting, then people can just browse those during review time and leave comments, and you can very quickly iterate. And if you're not completely technical, so you're a PM, then you can also look at those and try and sort of figure out what's happening. But it's not all great, because certainly the implementation and the specification can drift over time. There's nothing actually keeping them in sync. Maybe at the beginning they are in sync, but then some people add some new endpoints, change some parameters, and after a few months, the spec doc really doesn't reflect reality at all. And it's also really easy to be imprecise because this is just written prose. There's nothing forcing you to actually specify how things are. So another option is you could use an IDL, an interface definition language, like Thrift or protocol buffers or Avro. And here's an example of a very simple multiplication service defined in Thrift. And you see it looks very IDL-y. There's a multiply function. It takes 2 ints, returns another int. So what's good about this? Well, it can be very efficient on the wire. because you're using an IDL, behind the scenes, you really can compress things on the wire, and it's really efficient to decode. So we've certainly had situations where you send, I don't know, 10 megs of JSON, and it takes our Python services, 100 milliseconds to decode that. And there's not much we can do to speed that up. Whereas if we use Thrift, I think it's probably going to be more efficient doing that. But there are some downsides. So you cannot use nice layer 7 technologies such as HTTP caching. That's out. We're just at TCP now. It's difficult, but not impossible, to debug on the wire. And the quality of support for some of these IDLs can be a bit variable. It really does depend, especially if you're using a less well-supported language. Another option is to write lots of integration tests between your clients and your servers. And then effectively the tests actually become the specification. And you're basically saying something like, as a client, if I send this request to the service, then I should get back this response. So what's good about this? So you should hopefully be doing a little bit of integration testing already so that you learn about errors before you hit production. But it's not all good because integration testing is pretty much at the tip of the testing pyramid. You hopefully just have a few integration tests, and they can take a long time to run because you may have to spin up some databases, spin up some services. It all takes time to do this. So the iteration speed is very slow. So ideally, you want to find bugs before this point. Another alternative is you can write client libraries. So you hand your clients just a library in whatever language they're using, and they just talk to that library, and then behind the scenes, the library actually does all the communication on the wire. So what's good? It's a black box, the client lib. Consumers really don't need to worry about what's happening there. And from our own experience at Yelp, we have actually done this, and it can work. But there are still disadvantages here. If you're writing the client lib, then there's lots of boilerplate, sort of code that doesn't really add anything. You just need to put it in there. And you're probably going to be doing manual validation, checking the strings are strings, ints are ints, and the ranges are okay, that sort of thing. And you still haven't got the specification for the wire protocol. You're not actually forced to write that down at all. And so you probably also still need some integration tests as well between the client lib and the service. Okay, or is there another way? So we could stick with our existing HTTP and JSON infrastructure. We could then, just maybe we could invent a machine-readable specification language to declaratively specify what our endpoints and what our return types look like. Maybe you can see where I'm going with this. And then we could create a whole bunch of tooling to actually generate client libraries from these specifications of our endpoints. And then we could also create some tooling to perform server-side validation against these specifications. So are people sending us the right things? Are we returning the right things back from our server? And then maybe we could also create a really vibrant open source community around all of this. But what am I talking about? So I'm talking about Swagger here. And there's a URL there if you want to look at the Swagger spec. And now what I'm going to do is I'm just going to walk you through Swagger. So, the history of Swagger. It's been around since around 2011. That's when version 1 was released. And there have been a few different versions since then. I think in version 1.2, they actually formally specified the Swagger specification language. And then version 2, which was a moderately big change, was released in 2014. And that kind of got rid of a few of the pain points. And then just this year, it was renamed to the Open API specification, and it's supported by Google, Microsoft, IBM, and a few other companies now. So here is the pet store API. And you can actually try out hitting this endpoint. So if you curl it and you specify an ID, so 42 of a pet, and then pipe it through JQ just to format it nicely, then you get back this response. It tells you the ID of the pet and the category, the name of the pet, some URLs, and some tags, and a status. So this, for our services at Yelp, like, we do things that look a little bit similar to this. This isn't completely strange as a response from a service, and there's quite a lot of structure there. And as a result, it's quite easy to get something wrong when you're dealing with objects like this. So what would a Swagger specification look like for this? So there's actually a full spec at the URL at the bottom of the slide if you want to take a look at it. But what does the Swagger spec say? Well, it says it's version 2.0, and there's a description and an opaque version string and a title. And then the important things are these path objects and definition objects. That's basically where the meat of it happens. So I'm going to talk about path objects and definition objects in turn. So a path object for the endpoint that we just saw. So you see there's a path /pet, and then this path parameter, which is pet ID. And if you look down, you can see this pet ID path parameter is bound in the parameter section, name pet ID, and it's in the path, and then there's this description. And we see it's required. What type is it? Well, it's an integer, and there's this format, which is int64. And I'm going to talk a little bit about types and formats later, what choices you have there. And then there's this response type at the bottom. And you can specify response types for both success cases and also error cases. I'm just showing a success case here. So if you get a 200, it's a successful operation, and we return this pet object, which lives in the definitions section. And so this is just a reference. And the nice thing about Swagger is you can actually split these definitions out across different files, which can help keep it dry. So here's an example of another parameter object. It's not used in the example I just gave you, but it's used in the find by status endpoint. So what is this? Now we're saying it's a query parameter, and the name is status, and it's required, and it's an array, and the array contains strings, and these strings range over available, pending, or sold, and default is available. And so this is pretty powerful. We've got an enum type here, and we're actually going to be able to check that people are passing in the right enum values. So let's continue with our getPetById. So this response type, which is here on the right, I've given you the spec for it on the left. And so you can see that there are a couple of required fields, and then there are a whole bunch of kind of required and optional fields defined below. So there's ID, there's category, there's name, there's photo URLs, tags, status. And so this kind of makes sense, and I think hopefully you can see how this all matches up. What else can you specify in Swagger? Well, quite a common idiom is to return a map from strings to something else. And as we were retrofitting Swagger specs to our services, we kept hitting this case. And in Swagger 2 and beyond, you can actually define these very easily. And so here are a couple of examples. So a string-to-string map, you just say the type is object and the additional properties are of type string. And you can actually change the type, so you can have a string to a foo map if you've defined a foo object, and that just works. So what are these data types and formats? Well, your types, they range over integers, numbers, strings, and booleans. And then the format basically allows you to put a little bit more structure in the type. So you've got int32 and int64 for your integers. And then you've got things like dates and date times for your strings. So Swag will actually check, if you specify date time as a format, it'll check that you really do have a date time there. But you can also have custom formats, and this is where it gets really powerful. So if you specify a format that Swagger doesn't know about, well, Swagger will kind of ignore it, but maybe in your framework you've registered a validator for your email addresses or IPv6 addresses, and you can check that the strings are of that format. And we've actually done that quite a few times at Yelp, just to provide additional validation. So you've got a Swagger spec for a service. Where are you going to put it? So at Yelp, we check them into the service code base. Why do we do this? Because it basically minimizes distance between the spec and the code. You've got some other choices. You could actually put specs in a single central repo if you wanted. We haven't done that, but it could work. So modifying Swagger specs. So there really is no magic here. Currently, Swagger will not prevent you from doing something really bad. You need to make sure that all your changes are backwards compatible. If you like living safely, then just add new endpoints. Or if you like living dangerously, then go ahead, change some existing endpoints or remove some endpoints. Bad things could happen. There be dragons. I wouldn't recommend that path. So a brief interlude. What's the best thing about UDP jokes? Anyone? I don't care if you get them. Yeah. What's the best thing about TCP jokes? I get to keep telling them until you get them. What's it? No, I'm not actually going to keep doing this. Okay. So, you've got a Swagger spec. What can you do with it? There are several different things you can do with it. You can review the spec, or you can aggregate all of the specs across your organization into a single location so everyone can browse them. Or you can generate a client library, or you can perform some server-side validation, or you can do some testing. And I'm going to talk about each of those now. So API reviews. So here's an example of review board. We use this at Yelp, and here's a Swagger spec that we've just opened up a comment on during review. So you really can provide a lot of feedback at this stage, and quite often we do reviews for the spec first, and then we do the code reviews. And so this just looks like regular code review, which everyone should hopefully be used to. So browsing specifications. So at Yelp, we use a slightly modified form of the open source Swagger UI tooling. And on the right-hand side, you can see a bunch of different services, kind of blurred out just because I don't want to show you all the services that we use internally at Yelp. And so you can select any one of those services, and then you get the API for the service in the main kind of section there. And this actually integrates with our service discovery system, so that when you actually deploy a new service with a Swagger spec, it just automatically turns up here. So developers don't actually need to do any additional work if they've got a Swagger spec. So in the Swagger UI, you can browse all of these endpoints, and you can see the schema. It's great. But you can also perform real queries, because this ties into dev versions of our services. So you can go ahead and put, ID 1 for photo IDs, and then you can hit that try it out button. And it will actually go ahead, perform that request, and give you a response. So this is incredibly powerful. You've got all of these services, and you can interactively play with them from a single UI. And PMs love this. right? If dev's been working on a service, they can go ahead and actually try the service. They don't need to understand curl or JQ or know about the kind of complicated URL structure. This just works. So brief aside, how does Swagger UI work? Well, suppose you have a host which actually hosts the JSON, the JavaScript, and the HTML, and your browser downloads Swagger UI from that host. Well, same origin policy basically says in your browser that you can only communicate with the host which you downloaded that JavaScript from. But there's a problem because we actually want to go and hit the Swagger endpoints of all our services, but we're not allowed to do that. So how do we get around this? You can use cross-origin resource sharing, where your services actually return a header which specify who can access them. And we thought about doing this at Yelp, but it's really quite invasive if you have to modify all your services to return these additional headers. And so we got around that by using trusty Nginx. So Nginx just sits there and it proxies all the requests, both to get the Swagger UI and also to get the Swagger content from the services. And so it just sits there on a network, and your browser just thinks it's always communicating with Nginx. So this is just something to be aware of if you want to deploy Swagger UI. So we have a Swagger spec for a service. Let's generate a client library. So here's an example of doing that. You can run this code yourself if you want. You curl this jar, download it, and then you just run it with this generate parameter, and you specify what language. I'm doing Python here. And then you specify a URL, the -i option, where you can find the Swagger spec for the service. And then you say output it into the client lib directory. And you run that, and it will just generate to you a client library, just like that. And then suppose we have this client library now. How do we use it? Well, this is Python, but it would work with Java as well, or any other supported language. So you import the API client, you import pet API, which is defined in the Swagger spec. Then you construct your client, and then you basically pass it into your pet API object, and you just say get pet by ID of 42, and it goes off and fetches the response for that and validates it. So this, again, this is really powerful. We didn't have to write any of the boilerplate behind this. We don't have to write any validation code. This just works. But for Python, you can actually go a little further. So Python supports dynamic generation of classes, so at runtime. So at Yelp, we wrote this Bravado dynamic client lib thing for Python. And you don't actually have to do that kind of two-phase, fetch the spec, generate Python code, then load the Python code up and run it. You can all just do it in one step. So this becomes really powerful because you can interactively discover and browse your endpoints. And you see here that in just, I guess, 3 lines, you can actually fetch the spec, and then you can just invoke the spec just like that, and you get back the same response we saw before, basically. But now it's actually, it's an object. So it's, presumably there's a little bit of typing here as well. So something else is validation in your service. Here's a project for the Python Pyramid web app framework. Again, there's similar things for Java or whatever language you're using. And Pyramid Swagger, so we wrote this at Yelp. It supports several different Swagger versions. It does validation both coming into your service and also going out of your service. And it also has a few facilities for interacting with Swagger UI. So let's just walk through an example. What do you do here? Well, you add your route, as you normally do in these sorts of frameworks. And what Pyramid Swagger does is it actually checks in the Swagger spec that your URL is really there. And then when you're writing your handler code, so at the bottom of the slide, you then have access to this Swagger data dictionary on your request, and that contains all of your validated data that's come in. And Pyramid Swagger supports those custom formats that I was talking about. So suppose for some reason you wanted your pet IDs to be base64 encoded on the wire. Now, Swagger doesn't natively support this, but what you can do is you can register this validator, and then whenever Pyramid Swagger sees a base64 thing on the wire, it can automatically decode it, and then it can encode going back out. And here we see also there's validation, which is just try doing the base64 decoding. So let's see an example of Pyramid Swagger catching an error. So here we're hitting that endpoint that we saw before, but now we're using the string 42 instead of an integer. And Pyramid Swagger, before this even gets into your service, it realizes that this string is not an integer, and it throws an error for you. So it actually says 42 is not of type integer, and it says what it should be. So that's very powerful. We didn't have to write any of this code. Pyramid Swagger just did it for us. Or maybe in your pet store code, you've got this getPet function. You get a pet ID off the wire, and then you're going to return an object. This isn't what you'd actually do. It's just a kind of minimal example. But maybe for the ID we return, we make a mistake, and we put a string there instead of an integer. It's a very easy mistake to make, and you wouldn't necessarily immediately catch this error if you were doing something like testing or code review. You need to really exercise the right things here. But what does Pyramid Swagger do? Well, when you try and return it, it says this ID, it really should be an integer. There's been an error, so it catches it on the way out. So if you just made a few example requests to your service during testing, you could pretty quickly check that you're doing the right thing, because if you're returning things of the wrong type, then you're going to get an error like this. So let's talk about testing. So here's the situation if you're not using Swagger. So assuming you are using a client library, you've got two interfaces. You've got your client to client lib interface, which is presumably within a single address space on a single machine. And then you've got your client library to service interface, which is presumably going to cross the wire. And in each of these interfaces, there could be inconsistencies, and we've seen some examples of inconsistencies before. What does the situation with Swagger look like? Well, you've got your client to client lib interface before, but you can imagine your Swagger spec living on the wire almost, just checking things as they pass to and from the service. It doesn't actually live there, but it's a useful mental model. So our generated client lib is automatically consistent with the Swagger spec, almost by construction, providing there are no bugs in client lib generation, and also providing you don't go changing the Swagger spec, but we'll just kind of not think about that for now. And then you've got your Swagger spec to service interface. So let's look at the client to client lib interface. So this is a fairly standard testing problem. You're using a third-party library. You want to check that you are conforming to its interface. So what do you do? Well, you can mock out some return types, perhaps. And your type checker can probably help here if you're living in a typed language. So what would be really nice for Swagger would be if it actually supported kind of running in testing mode. So you could say to your client lib, hey, I don't actually want you to make requests on the wire, but when a request comes in for this endpoint, please return this data. So it doesn't currently support that, but hopefully that will happen sometime soon. And then we have the Swagger spec to service interface. So as part of your testing, given you've got a Swagger spec, you could use an external validator just to check your requests and your responses are consistent with the spec. Or if you're using something like Pyramid Swagger, well, that's already kind of built in, so just fire some requests at your service, and it'll tell you if you're violating the spec. What else is there? So there's Swagger Hub, which is a pretty new service online by SmartBear. And here you can actually enter your Swagger specs and straight away see the documentation for them. And on the right-hand side, you can also generate client and server implementations and just download them. So you don't really have to download any of that tooling. It'll do that stuff for you. And you can also share your specs between other collaborators. So this is pretty exciting because it's kind of like GitHub for Swagger, and I can see this becoming a very easy way of collaborating on APIs. So Swagger isn't the only way of specifying your HTTP JSON interfaces. There are a few other languages for doing this. One is API Blueprint by Apiary. And the nice thing about this is it's kind of designed to be more human readable, and behind the scenes it actually gets compiled into something a little bit similar to Swagger. So here's just an example of a pet store-like interface. I haven't used this, but it is an option out there. And another option is IODocs by Mashery, and this looks very similar, I think, to Swagger. And you can see it's just specifying an endpoint, a get endpoint. So, conclusions. So Swagger provides a really easy way to define JSON HTTP interfaces, both for new services and also retrofitting onto existing services. Once you have an interface, you get a whole lot of tooling for free, right? The cost of entry is that you write your Swagger specs for your services, but once you're in, there's a lot of value. So you can automatically generate client libraries for many different languages, and you can automatically perform validation of requests and responses. So the unicorn is happy now. No more tears. We fixed the unicorn's world. Are there any questions?
So it seems like you do your specs outside of the actual code in some other file. I know with PHP I've seen it where you can do it defined with commenting. Can you do that like on another language as well?
Right, so the comment is that the examples that I gave you were with Swagger specs separate from the code. Can you do Swagger specs in line with code? And I think you've seen an example of it done like that in PHP where it's actually with the code. Yes, you can do that. At Yelp, we found it quite valuable to actually have the specs separate from the code, because that way you can review specs separate from any implementation. But it kind of depends on what you want, and I can also imagine cases where it's a lot easier to inline the spec with your code. Because I know that for some of the Java frameworks, you can put the Java annotations on your methods, saying what types it takes, what types it returns, and it will automatically generate a Swagger spec from those. So yes, that is an option.
So I was wondering how to use Swagger with like JSON API where it envelopes the JSON response.
So the question is, how do you use Swagger with JSON API where it envelopes the JSON response? So I'm not very familiar with JSON API. But presumably, if Swagger can actually express the JSON API types, then that would work. I imagine JSON API uses pretty standard objects and types like strings and booleans and integers. And so I imagine you could code that up as a Swagger spec. But again, I don't know all of the details there.
There's no way like having a base template that you can inherit into your Swagger doc and say going to graph that base template.
Oh, so the question is there a way of specifying a base template that you can inherit in your Swagger specs? So there is support for inheritance, but I'm not quite sure how that would work with JSON API. So, yeah, not sure is the answer. Any other questions? Okay.
How this kind of fits into workflow? So you have a project manager that we use Swagger, and that generates enough detail for him to hand that off as a spec to a programmer.
So the question is, how does the workflow work? Does a PM sort of define the spec and then hand it off to a programmer? So at Yelp, PMs are involved with details of the coding, but we normally have the programmers actually take the lead on defining the specs, and the PM can work with the programmers. So it's not like waterfall, PM does this, hands it over to the programmer, then the programmer does the implementation. It's much more collaborative. So the question is, are there any other tools that we use for handing off specs from PMs to sort of implementers? I know that we still do have some written spec documents for some of our older APIs, and so those still exist. And I think there might be a little bit of automated tooling around those. So yeah, like spec docs are still used by a few PMs. I think if I can remember correctly, the teams who are still using spec docs do not use Swagger. So they really are just going from the spec doc to the implementation. Okay. Any other questions? The back. So the question is, did we encounter any disadvantages to using Swagger? So before Swagger 2.0, there were some idioms that we could not encode for existing services. So those map types, I don't think we could actually do those, which prevented some adoption. Other issues, let me think. The validation can be a little slow. It's not really slow, but it can be noticeable, especially if you're validating large data structures. And so I think one or two teams have noticed these problems, especially in something like Python, which doesn't tend to be quite as fast as Java. And I guess the other problem, if you can call it a problem, is that Swagger forces you to write these things up front. And sometimes that can be a bit of a challenge, right? Because it keeps you honest. I would say that's a positive, but it's an additional step in the road. Okay. So the question is, are there any problems that we've had? Right. Yes, so are there any problems retrofitting Swagger specs to sort of horribly designed, maybe, legacy applications? So there was the map problem that I spoke about before. That problem is now fixed. I think if you do some kind of odd patterns, like if you could write an endpoint, if it gets an even number, it returns a string. If it gets an odd number, it returns an integer. That might be quite hard to type in Swagger. And you might say, you shouldn't be doing that, maybe, but it is what it is. I believe so. Right. Right. Yes. Those are the cases that I have come across during retrofitting of Swagger specs. But there may be other edge cases, but I haven't seen them. So paging for results. So you would pass in a kind of an offset parameter. So that if you want to do paging, then you can actually just pass, as part of your request, there's probably a query parameter that says, here's the offset, and here's the number of results for that offset. So it's not going to automatically make sure you're doing your paging correctly, but it will check that you're passing integers for your offsets and your sort of window sizes. Right. That's correct. Out of the box, it can do most things that I have seen. Yes. Okay, back left. Right, so the question is, am I familiar with Apiary and how does it compare with Swagger? I only have given it a brief glance, actually, so I can't really give you a full comparison. Certainly what I like about Swagger is that it seems to have a very large, vibrant open source community, and the tooling seems to be very good, and so that was why I went with Swagger, but I can't really give you a comparison. Okay.
Have you had experience with graphics web stuff, Angular or JavaScript? I noticed this JavaScript package, or an NPM package. How's that working with Swagger?
So the question is, have I had an experience using Swagger with sort of client-side stuff? The answer is no. So right now we're using Swagger for all of our, well, not all of, the majority of our back-end services. So I can't really talk to how it would work with Angular or something like that. But presumably, you know, it's still a pretty similar game where you're just typing things and checking and validating. So I wouldn't imagine it's hugely different. Okay. So do we integrate HMAC? Sort of authentication type things. Do we integrate HMAC? I am going to punt on security questions. Okay. Anyone else? Okay, let's call it a day. Thank you very much. Yes, hopefully. How are we doing? That was a bit short. I wanted it to go on a bit longer, but yes. It's been fun. That's so funny. So what does that give you? So you get a 300. That's so funny.
Testing, 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 testing.
See your rush shirt there. Did you go to the release party or did you get that after the fact?
I got it after the fact because I'm a size that didn't sell out immediately.
Yes. Nice.
I realized later I probably should have brought some of the rest of the camp shirts just like inside reference with everybody.
Yeah.
All right, it's 3 o'clock, so I'm going to get started. This is Rust system programming for web developers. Before we start out, I do have a confession to make. I am a Rustacean. So if you write Python, you're a Pythonista. If you write Ruby, you're a Rubyist. If you write Rust, you're a Rustacean. Not Rustafarian, Rustacean. And this little guy on my shirt is the official Rust mascot, a little crab, a Rustacean. And that's what I do at night. If you write PHP, does anyone know what you are if you write PHP? That'd be misguided. Actually, I kid. I write PHP during the day. I've been doing it for 10 years. But I love Rust. I fell in love with this language. And so I work at nordstromrack.com/HopeLook during the day writing PHP and managing. And I write Rust sort of on the side. So before we get into Rust itself, let's actually talk about what system programming is. There's no definition out there that everyone's going to agree on about what system programming is. And those of us in the Rust community seem to have coalesced around this definition of system programming is when it matters. So I'll give you an example of when it doesn't matter. I'll pick on Ruby this time. Ruby is slow, but it doesn't matter because the database is the bottleneck. So when you're writing Ruby code, we're not calling that systems programming, right? Because it doesn't actually matter if Ruby's a little slower than where you're writing it in C because your bottleneck's the database, right? There are a couple characteristics that you're going to sort of see if you're systems programming. You're not going to have a garbage collector. You're going to have to manage memory yourself. You're going to have fine-grained control over your memory management. So we see that a lot in C or C++. and you're going to have zero cost abstractions. So what that basically means is you're writing code that's sort of against the metal or against the hardware, right? You could be flipping registers on and off if you want to. You can represent a data structure in the exact size of memory that you specified. You can make entire programs sort of allocate memory on boot and then allocate nothing afterwards, running just on the stack, and then free up at the end. So you have a lot of control. So that is systems programming. And let's talk about why I think Rust is a great systems programming language and why I think web developers should take a look at it. Let's start with some history. So Rust is a language that's sort of been developed by Mozilla. It was developed with a primary use case in mind. See, Mozilla runs, as you all know, the Firefox web browser. And since the web is such a popular place nowadays, there's lots of events like Pwn to Own, where a bunch of security researchers or hackers will get together and they will present their exploits. And they do this with Firefox and Chrome and every single browser out there. And Mozilla sort of noticed this pattern, where all the exploits were basically coming centered on this sort of one vulnerability, which is a data race. And that would sort of happen when they would sort of have all these sort of threads running, they write C++, all this threaded programming going on to make Firefox fast, even though Chrome's faster. But they got all these threads going on, and there'd be sort of some mistake that someone would make with the way the threads are working and sort of sharing memory that would cause a data race. And hackers would take advantage of that and make the web browser do things like a remote command exploit, or they would allow it, they would make it do something like going to like a web page or fetching a resource that it shouldn't. And this was driving Mozilla crazy. They wanted to fix this. So Rust's primary motivation is to sort of fix this problem that Firefox was having about sort of not having some sort of safety checks around this, because threaded programming, even for the most experienced developer, is super hard. So what they did is they developed, they're working on developing now a web browser engine called Servo, which is sort of a replacement to Gecko. So if you don't know, Firefox uses the Gecko rendering engine to actually render out the HTML and the CSS on your web page. So they're not really building a new browser, but sort of building a new engine. We actually already see elements of Rust and Servo kind of being feathered into the existing Firefox browser. So before we get too far, I'm talking to a bunch of web developers, hopefully. Has anyone here actually written a Rust program before? Also a fair amount of Rust stations in the room. That's great. Welcome. But if you're a web developer, you might be asking yourself this question, is Rust good for web development? And the Rust community sort of has this penchant for making these websites called like areweblankyet.com. And am I on the wrong page? What's going on here? There we go. That's what I wanted. Yeah, areweblankyet.com. You can actually go this and actually talk about writing a web browser, a web service in Rust. And you can do this, but I think it's too early to tell if Rust is going to be good for web development. Rust is primarily a systems programming language, so we're talking about that. And really the problem with Rust in the web development context is that the web's made up of strings. HTTP is a bunch of strings coming in. Your database connection is usually a select with a bunch of strings coming back out to your Ruby or PHP or Python code. And really converting all those strings to types normally isn't worth it, right? Web requests, we hope, are under like 200 milliseconds. We're trying for expressiveness in our web code. We're using GC to kind of save ourselves from memory management a lot of the times. So it's just really not worth it to sort of do that. Also, we don't really need fine-grained control over memory because, again, we're only 200 milliseconds is our span. If there's some memory leak or some memory overhead, the request is going to be finished up quickly anyways, and we'll start over again. Also, Rust is a compiled language, so there's a compilation step. So we're not really going to focus on Rust for web development. I'm going to sort of slant this over to why web developers to sort of look at actually getting involved in a systems programming language. Yep, so Rust plus web developer, I contend, is going to can be a systems programmer, right? So let's talk about this. I think I did actually skip a slide. So Rust sort of provides these three constraints, right? Memory safety without garbage collection, concurrency without data races, and abstraction without overhead, which we talked about is sort of what makes up system programming. And we're going to sort of go through these and how they can be applied to web developers. So I sort of have this basic theory, right? Anytime a new programming language comes out, there's a bunch of people will get on the internet and they'll say something like, oh, this language is going to replace all the use cases for this other language, right? We saw that with Rust too. Rust was sort of coming out. It was 8 years in the making. It's at 1.6 now. People were sort of discussing a lot, oh, do you think Rust is going to replace C or C++? I don't think that's really actually the case. If you're writing C or C++ right now, you're probably pretty comfortable in a language that you've been writing for years and years and years. And you might switch, but a lot of people, like, they have no reason to switch. They're working a day job using C or C++, and they sort of invested all this time and energy in getting familiar with that, and they can sort of, work through that. I actually think that Rust won't be a C++ killer, and I think instead web developers are sort of the largest group out there right now of people in like the software developing community, and lots of new people coming in. And I actually think Rust is sort of well positioned, given some of its features, to actually be attractive to web developers and actually grow the overall pie. So there's really not a focus on actually cannibalizing that existing blue blue pie chart area of C and C++ developers, but I'm actually arguing, like, I think Rust actually can put a nice slice of new systems programmers into the community, which I think is sorely needed. And I think there's some historical context to this, right? Like, I just didn't make this up out of thin air. We've sort of seen this. So, was anyone sort of was programming when Rails came out? Remember the same thing happening where there was a bunch of debate going on in the web development community, talking about, like, would Ruby on Rails sort of, unseat PHP as the dominant web language? Would it sort of take over? And you see these, blog posts flying back and forth. Rails is faster and PHP is faster, and sort of it's never ending, right? And there are benchmarks lie. But what no one sort of understood at the time is, like, cloud computing is in its infancy, right? Like EC2 starting to sort of get more popular. There's other competitors out there. We're virtualizing so many things. And you have a whole generation of ops people that they don't even know how to work in the cloud, right? They're used to, like, procuring some hardware, like setting it up, with some custom bash script. Maybe they're using CF engine. And then, like, that thing's just going to run, and we're going to pretend like it never, like, shuts off. And if God forbid it dies, then, there'll be some heroics going on. And what happened with the Ruby community, right? Like, they're wanting to, Rails is new, people are coming in, they want to actually get this stuff in the cloud, and there's no tools for that. And then the Ruby community finds out is Ruby's a great DSL, and they start writing the tools themselves. And all of a sudden you get things like Capistrano for deployments. You get Puppet and Chef as a much better replacement to CF Engine for configuring servers. You have multiple sort of ways of running multiple Ruby versions in development, and even, God forbid, production if you wanted to. You have awesome sort of developer tools like Vagrant, which is a Ruby script around VirtualBox that makes life much easier for us, and things like Sensu, which is a Ruby replacement for Nagios. So all these great, so Ruby didn't create the DevOps movement, but certainly what they were doing, they found that Ruby wasn't replacing PHP. It just actually created this entire generation of DevOps people that have built a bunch of tools that basically everyone in web development community uses or has been influenced by. So that sort of happened. We kind of see it actually going on now, right? You take a UI developer, slap some Node on them, all of a sudden you got a full stack developer. But why is this, right? So I was a PHP developer when Node came out, and I remember looking at Node going, why? Why would anyone want to do this? And a bunch of other people who were writing Python and Ruby said the same thing. Like, what's going on here? And Node is a new technology, right? Like, nothing that Node sort of brings to the table is brand new. We've been able to render JavaScript on the server for years using Rhino. We've been able to do async I/O using libev, I think was that what it was, before libuv was created and used in Node. So there's no new technology here. It's been around at least a decade. Why all of a sudden, like, is this such a powerful movement? Like, what's going on here? And if you sort of think about it, like, web's eating the desktop, right? And if you're a UI developer, your requirements being given to you are like, hey, make the web feel like it's native. I want fast and everything dynamic. I don't want to reload the web page. Just make everything like single-page apps. Ajax load everything. So these UI developers are writing HTML and CSS and JavaScript. They're going to the Ruby person and they're saying, hey, I need you to give me like a lot of this like event-driven sort of interaction. I need you to do a lot of this stuff for me. And they're going like, what are you talking about? I know like REST. That's all I do. And they're like, no, I want WebSockets. I want, all kinds of like, nice interactions. And there's this friction, right? So with Node, all of a sudden you took a UI developer who was fighting with their backend engineer, and you're like, hey, here's all the tools, you can just do the whole job yourself. You already know JavaScript, here you go. So now all of a sudden you have a full stack developer, and it's happening right now. And for a long time, the server-side people just didn't get it. You saw blog posts like Node.js is a cancer. People putting up blog posts like, hey, Fibonacci runs really slow in Node. And as we all know now, it's more of a mature ecosystem. Like, it's really powerful. It's really good. It complements a lot of what people are doing out there. And it didn't, so no one lost their jobs doing PHP or Ruby or Python development. But what you have is a whole generation of people who are only working in the browser, now working on the server side as well, and providing a lot of influence in the community. So I think the same thing is going to happen with Rust, right? You're going to actually have you can have web developers, and you're going to sort of convert them into systems programmers. And that's not to say you're going to stop being a web developer. You might actually just do both. Like, you're just going to sort of, let this sort of enhance your tool set. And so, and why do I think this is needed? So as we all know, like 10 years ago, we were building monolithic applications, right? One repository, a web server, maybe your runtime behind that. And if you wanted to scale that out, all you kept doing was horizontally scaling, right? Spinning up more VMs or procuring more hardware. And that's, unless you were like the 0.1% of the industry, that's basically how you scaled. Throw more databases behind it, read clusters, right? Now, even sort of the average sort of engineering shop has microservices and all these different parts of their application. And if you start going through like some of like the concrete examples of each of these, you're going to find out like none of them are actually written in the languages web developers know, right? Yet we're highly reliant on them. So if we're talking about application caching, like Memcache or Redis, both written in C. HTTP caching layers, Varnish and Squid. Job queues. I think Rescue might be like the one example here if you're in the Ruby community where you have like a Ruby sort of implementation of a good job queue that you can use. If you're in Python or PHP, like, you're using like Yearman or Rabbit. Relational NoSQL databases. These are all written in C or C++. Search databases is the next other exception here. Those are written in Java, though any ops person hates this because, when you're running high workloads and the GC pauses on you at your most critical time, you're getting really mad, and so you fight with it nonstop, and every ops person wishes that these are written in C or C++. Load balancers and VMing containers, like we're all like VMing and Dockerizing everything under the sun right now, right? Again, all written in a non-web language. So we're highly dependent on this entire ecosystem of software that web developers have basically very little access to. And what you basically have is this massive knowledge gap, right? What makes it worse that all this stuff is open source. So there's really no one getting paid to do this stuff, which means you have very, very few people actually working on this open source software that actually have the know-how because it's C or C++. And this is bad for a few reasons. One, like we've seen burnout in the community. Also, we've seen that a lot of these maintainers don't have time for things like important ancillary tasks like documentation or putting out proper releases and things like that. Also hinders the state of the art. When you don't have people sort of like fresh people getting into a certain area, sort of a couple winners emerge, and then things sort of stagnate, right? We saw this with the web browser for a while, where where web developers weren't actually involved in the web standards. You had a bunch of C and C++ people that were developing browsers, sort of figuring out how APIs and the web worked. And when they would come out, all the web developers would say, like, what are you doing? Like that does not match your use case at all. Only recently do people in the web community have they started joining TC39. We've been getting things like ES6 and ES7. Like, that wasn't an accident, folks. Like, it really took web developers getting involved. I think, likewise, we're missing core use cases in the web community because we're not getting involved to solve parts of our web stack for ourselves because we know best. And there's a clear example. I write PHP during the day all the time. PDO is the sort of the database adapter abstraction in PHP. It means PHP data objects. The person who wrote that is a C programmer. He doesn't write PHP. And the way he wrote it in the constructor of PDO, when you do new PDO, what people normally do in the bootstrap, that actually makes the network connection to the database. Like, no web developer wants to make a connection to the database in the bootstrap of their code unless they're explicitly saying it. And you have to like kind of work around this as a PHP developer. Like, everyone has to do it. It's crazy, right? And it's because I think, Wes wrote a great library, but he missed a core use case because he wasn't actually involved in the PHP community. So Oh, go ahead, I'm sorry.
I think you're overdoing the sales job. If let's say you're dealing with a tiny machine like an APRA or something with 30 pieces of generated, it's either C or this. So if anybody's going to build a web interface or something this small, they have to do this.
Yeah, I think for the video, same name, I'm overselling it. I'm sort of laying out sort of like the background of why I think web developers are getting involved in Rust now. And we're going to go through certainly a lot of code examples, but I thought sort of the history was important to sort of present. Yeah. So there are some barriers to entry for web developers to get involved in systems programming, right? Why haven't people, and this is why I think I want to set this up. Like Rust is fundamentally different here, right? Web developers aren't getting involved in C and C++ because it's unapproachable, in my definition, right? There's a problem with memory management. When you can sort of compile your C program and it compiles fine, and then you put it into production, and all of a sudden it seg faults on you at the most critical time, like you're not going back. Like that's a super painful experience. And so if you're a web developer trying to get something done and try to get this critical task out, like that's not making you look good. C or C++ sort of provide that foot gun for you. And you can't sort of rely on GC if you're doing systems level stuff, as we discussed. And I think a lot of web developers don't want to write C or C++ because it's not an expressive language, right? When we write Ruby, we like how expressive it is. When we write Python, we like not having to do semicolons. And we shouldn't have to necessarily give all that up if we want to write systems programming. And a lot of times we don't need types, and we've kind of grown accustomed not having types. So Rust can kind of solve a bunch of that stuff, right? So these are the 3 tenets of Rust, and we're going to go through and talk about how they allow you to do memory safety, give you fine-grained control, which is your cake, and sort of not let you seg fault, eat it to them. We're going to show, I'm not going to get too much into concurrency because it's hard to show in examples, but we will get into a lot of abstraction without overhead. But I do want to make sure everyone understands, like, I think 2 is super important here too, because as we know right now, we're taking a single piece of hardware, like a server, and we're breaking that down into virtual machines and Docker containers. I think at some point pretty soon here in the future, we're going to see a lot more use cases for something like Apache Mesos, where we're taking actually multiple machines and trying to make them work in concert together. And right now, trying to do that, if you have architecture that's horizontally scaling, you sort of know that that actually is a lot of time and effort to make sure those things are coordinating correctly. So having concurrency without data races is super important, I think, for sort of the future where a lot of this system stuff's going. All right, so let's get into some code examples. Rust right out the gate has basically this concept of ownership, which allows us to sort of have memory safety without garbage collection. We're going to go into some examples of how ownership works. So I'm going to start walking you through Rust syntax with the examples. If any of the syntax doesn't make sense, let me know. But in this example, we're defining a function take that has a single variable v of type vector of signed 32-bit integers. And then below that function, we're going to actually define a variable v that is a vector of 1, 2, and 3. And we'll pass that variable v into our take function, and then we're going to print out below that the first element of v. In any other language that you've probably been exposed to, this is perfectly fine, perfectly sane, and perfectly normal. It'll compile, it'll work, it'll run. In Rust, this is an error. And it all comes down to ownership, right? We actually passed our v into the function take. And once we did that, we have given up control in that scope of using that value v again. I'll show you the code again. So line 3, once we pass v into take, we are no longer allowed below to use v or access v anymore. And this fundamentally, like there's references and other stuff that Rust introduces here, but this fundamentally is how Rust gives you memory safety without sort of the garbage collection piece here. It basically ensures at compile time that you're not doing anything that would basically cause problems, right? And this is really nice because it solves a whole class of problems that C or C++ don't solve for you. You don't have segmentation faults anymore because you're not basically allowed to sort of use after free, essentially, right? Or even use before you even allocated it. The compiler is sort of using this rule called like the borrow checker. It's using this borrow checker is going through and basically making sure at compile time you're not doing anything that would basically blow up your program at runtime. And you also don't have memory leaks anymore. because Rust is sort of handling the freeing. After it's allocating, it's also handling when it's supposed to free. So you don't have to worry about this whole notion of I need to have functions that are dedicated to allocating memory, and then making sure I'm only freeing that memory, and then nothing else is sort of accessing it, right? And if you've written C++ before, you know this is sort of just a chore to do, and Rust does it for you for free. The problem is when you sort of start out with Rust, you're going to start fighting the program, because as you saw, like that was a perfectly valid program that we wrote, and we all know that like that's how we write code, and Rust doesn't let you do that. And so when people start writing Rust, they normally start fighting the borrow checker. And I'm like, no, that's perfectly normal. I do that in like this other language. Why won't you let me do that? And really what's going on here is the borrow checker isn't doing anything actually that you shouldn't be doing. If you're actually like a grizzled veteran C++ developer, you basically have internalized like these conventions of the borrow checker into what you just sort of know. Like it's like tribal knowledge to you. You go through and read like some like the best C++ development books will actually like outline these steps, like make sure you do all these things. And what Rust did is basically codify that into a compiler. So what Rust is, you know, when you're fighting the borrow checker, kind of take heart in that you're kind of making an investment, and that the compiler is literally teaching you, painfully at times, because it doesn't care how frustrated you are and it doesn't actually go on vacation, but it's teaching you to become a systems programmer. And you could actually take those same rules and apply it to other systems languages and be just as successful. One thing I actually really like about this too is you can contribute back with confidence, right? How many people have sort of wanted to put a patch into a large program, either at where they work or even in open source, and have kind of felt a little uncomfortable about actually pushing that pull request button, right? Because even though like the tests pass, like you're like, I don't know, like it might blow up at runtime. I might have missed something, right? And you know, it's kind of scary, especially if you're new to that community or you're a new developer. Even if you're seasoned, you look like a knucklehead if you just sort of miss some obvious thing, right? And the great thing about the borrow checker, even though you're going to fight it at first, you're going to get to the point where, like, when that program compiles, you pretty much know that it's going to work. And if it does blow up, it's not going to be for some obvious thing. It's going to be for something kind of crazy. And so, like, I myself have contributed to Rust core, and I'm not like that good of a programmer. But once the thing compiled, I just felt like I can push the button here. I can actually send this patch over the wire because, like, the compiler told me I'm a good systems programmer, and for this particular piece of code. Cool. So great. So now this is why Rust is so compelling in terms of writing safe code. But I did talk about we don't want to give up some of those aspects of scripting languages that we like, right? So let's get into some of these things that Rust does so that we don't look like we're actually writing so much sort of C or C++ code. So Rust spends a lot of time on ergonomics, and we do think writing the code should be as enjoyable as writing it in a systems scripted language. And we want the compiler, we use the compiler to figure out all this borrow checking stuff, right? All this ownership stuff. And we also use the compiler to figure out all this sort of boilerplate stuff that you might do in other languages that have strong types, and we just sort of let the compiler infer it. The canonical example here is like in Java, right? You have to define the types on both sides of the assignment. It's like, why? I just defined it on one side, just figure it out on the other side. And what we end up doing, right, is instead we produce IDEs that basically fill in all the boilerplate for us, right? And instead of using IDEs, Rust, let's just stick it in the compiler. So here's an example, simple example. We're going to define some variable foo that's going to be of typed signed 32-bit integer, and we're going to assign it to the variable 5. And as humans, we can all reason about very quickly, like, that's a number. I don't need to specify the type, so neither does the compiler. And this looks like a lot of languages that are like scripting languages, right? Let foo equals 5. No type necessary. That's great for like type, like assigning like variables of types. We also can go one step further. The compiler can even figure out, in certain cases, how to even default the return type. So here, we're getting a little more complex. This is how Rust defines a closure. So we're going to define some variable f, and it's going to define a lambda function that takes in a single variable x of type signed 32-bit integer. And it's going to return a signed 32-bit integer, and it's going to return x. And this is an example of the identity function, if anyone's curious. And this is how you write a closure in Rust, or Lambda function in Rust. It's pretty terse. We can even get better. That is how you can write that same function in Rust. And again, that looks a lot like a scripting language. So you can go through a lot of your Rust code and not actually worry about specifying the type. And that's nice because, I'm sorry, go ahead.
How does the compiler know that that's a signed 32-bit integer? Can I pass in a string?
Yeah.
Return a string?
So I'm going to say that by actually writing it, so not only is it nice to not have to write the type, in certain cases, this is actually more expressive even to your code, because you can use the same function to actually allow multiple types come through, and the compiler will know that. So it's even actually better, like this is encouraged, right? As programmers, we're sort of taught like laziness is a good thing, and here it's showing up in the positive. All right, and we're going to go into a little more complicated example. These apostrophe A's things are called lifetimes. And so what we're doing here is we're defining a function that's very similar to our identity function called silly. And I'm introducing this concept. I'm introducing a lot of concepts here, but ampersand means reference. And that lowercase str is a string type, one of the string types in Rust. So we're passing in some variable s of type string and pass as a reference and passing that reference back out. And we see like these apostrophe A's, all of Rust's functions require you to sort of define these things called lifetimes. And that's how it actually figures out how long things like references should live for. And it's all really complicated. You have to be like, some programming language theorist to actually figure out a lot of times when certain lifetimes can be used. But the great thing about Rust, again, we're using the compiler. Like 99% of your code does not need the lifetimes at all. The compiler infers it. This is actually really nice because we get all the power of lifetimes without having to worry about it. So if you're a new developer and you're trying to do something in Rust, you don't want to have to start thinking about lifetimes. You're trying to just get something done, right? And so the default here is lifetimes. Lifetimes are there under the hood, but they're just sort of like inferred for you. And when you want to actually turn on like the advanced switch, like you can switch that advanced switch on and start telling Rust, no, I know exactly what I'm doing. Here are my lifetimes. And be really explicit about what you want to do. So you get all the control with sort of none of the penalty. All right, at this point, we've sort of kind of kept it pretty introductory, and I've been introducing a lot of things that are probably pretty basic. We're going to sort of step up a notch here to a little more theoretical stuff that's going on. If anyone has any questions, please stop me and ask. So, optional correctness. Yes, go ahead. Great. So the question is the borrow checker a reference counter? No, it's not. The borrow checker is a program that by default there's no sort of reference counting going on. We're literally at the metal level where like C is. There's a couple phases in the Rust compiler. This is the first phase that it goes through and just sort of makes sure the semantics of your code aren't violating sort of any of these constraints. So it's not a runtime thing. It's done at compilation time. Lifetimes, yeah. Think about lifetimes as basically it's less of a scope. It's almost like typifying sort of how long a reference to a variable should live. Lifetimes are one of those things. I introduced it. It's going to come up if you're getting into Rust. You don't need to actually worry about them hardly at all, but you kind of want to know what they are in case you run into something when you're using a reference. I would say most people have written Rust and they'll go months without ever needing to put one lifetime in place. So they're there. Be aware of them. Don't be scared of them. All right, optional correctness. One of the things I love about Rust is it sort of takes this nice balance of theory and applying that theory to actually real-world problems. And as we know, the real world is not always sort of on our terms. And so, I like a language like Haskell. It's great, but you have to jump through a lot of hoops sometimes to make your programs work. And I think Rust strikes this really nice balance. And I think we can sort of, a great example of this balance is in Rust, you can do really return types, right? So we've all seen this type of code. We're going to let R equal the value of some function, return type of return value of some function. If R is an error, we're going to return early, return false, and then we'll go down our happy path code, right? We all write that when we write like our normal code, and we write that in Rust too. But Rust also has this monadic type, right? We're going full burrito now. This monadic type option that can wrap a type T, so any type T, it can wrap this. And if you're not familiar with option, it's like the either type in Haskell. Option can basically say, look, if there's something here of type T, or there's nothing here, right? So it kind of maintains these two states. And if you're going to go like to programming language theory sort of side of things, this is a monadic type, and monadic types are not allowed to return early. Rust is like, whatever, you can return early. So what we have here is an example, let variable foo equals some string bar, and we're going to use the find function on foo to find the character B, right? And this match statement in Rust, it's kind of like a switch statement, right? But it makes sure like you sort of cover all the different use cases. So as I said before, option is either there's something there or there's nothing there. So if there's something there, some character C there, then we'll just return C back to our variable. So C, is where that position is. And we're good. And that's what this code is going to do, right? We can have a different example where our string is nope, and B's not there. And we're going to go into this other branch of code, this other arm of our match statement, where it's none. And we're going to call this macro panic, which basically means like fatal error, bail out of your code, stop running the code. It basically return early type. So, when people sort of, if you're a programming language theorist, you see option like, I love monads. But Rust is like, look, you can return early too. So you kind of get all the power of monads, but sort of all the simplicity of sort of returning early. Which is just easier, right? Like you don't have to like sort of contorting your code to say like, okay, I get only one return type at the very bottom of my function scope. You're trying to figure out how you can break your functions into even smaller functions to deal with sort of the different if-else statements that need to happen. It really makes things much more approachable. And this pattern right here is so common in Rust that they actually made it even easier to do. And they have this method called unwrap. So this is the same thing as before, that basically unwrap will say, look, if you found what you were finding, I'm just going to return it to you. And if you didn't, I'm just going to blow up the code. You might be like, man, why would Rust put that in there? Like, I thought you said this was supposed to be like memory safety and like really good systems programming stuff. Well, it's true, but if you're starting out in Rust or even starting out trying to solve a problem, you're not worrying about correctness, right? You're trying to hack your way from like start to finish and get something compiled and something generally working to see where you're at, right? We don't normally explore new spaces by doing TDD first, right? TDD is after you've already sort of mastered your Ruby or your PHP or your Python. TDD is when you're sort of just trying to, you're on Rails. If you're starting out Rust or sort of exploring some unknown problem where you're trying to figure out like some weird protocol and you're twiddling bits, you don't want to be dealing with TDD, right? No, you don't want to be dealing with really correctness either. You want to turn that off, and so you can use unwrap. So a lot of times what people do is they'll write their code and they'll just do their first pass and everything will just be unwrap, unwrap, unwrap. It's fine if it blows up, it's not production ready yet, that's okay. And you can go back later then and actually say, like, I'm going to now actually handle like errors properly. Log them, you're going to bubble them up, you can do all these different things. So it's really nice. Again, a pragmatic approach. And really, I think it goes down to, Rust sort of says, like, the programmer knows best. Like, we're going to sort of put all these defaults in place, and we're going to sort of set this really nice system programming language up, but the programmer knows best, and we'll sort of allow them to sort of override things when they want to. So much to the point that Rust also has this notion of unsafe, where I sort of told you before you had to satisfy the borrow checker. If you wrap code in unsafe, borrow checker says, I trust you. So here's an example where we're actually creating the sparkle heart emoji out of a vector of bytes. And we're saying, like, look at Rust, trust us. These are valid UTF-8 characters. If they're not, then that's on us. And what this is sort of nice is, like, again, it allows us, if we're trying to really take theory and apply it to the real world, sometimes the real world is not on our terms and we need to do something crazy, right? And in this case, we're sort of demarcating, like, I need you to trust me right here, Rust, and also to all the other developers out there, like, hey, I need you to trust me here. Rust doesn't have my back here. I'm saying I got this. So let's talk some about zero-cost abstractions, what I sometimes call mullet-driven development. You're going to get all the sort of the expressiveness, or actually all of it, a lot of the expressiveness of Ruby. So you get sort of the Ruby in the front when you're writing your code, but you don't take any of the performance costs. You really get like C in the back, right? This is great. So let's go through some examples here. Right here we are defining some variable n and then taking a range of numbers 1 to 10. We're first mapping them. So we're multiplying all those numbers by 2, then calling filter on them. So any number greater than 5 we're dropping, and then we're adding those all up with our fold function here with an accumulator. This looks very similar to something you might write like in Python or Ruby, right? And this, like, if you're like, real cutting edge Rubyist at this point, like you're like no for loops ever. I map everything. It's great. You can sort of do the same thing in Rust. But if we wrote this in Ruby, right? Like first we're going to basically loop over every single one of those numbers, 1 to 10, once for map. And then we're going to loop over the numbers again for filter. And then we're going to loop over the numbers again for fold. And that's going to be basically 3n times. Now, if you write Ruby, again, it doesn't matter because that's not what you're trying. You want expressiveness. You're not trying to optimize your code for performance. You want expressiveness, maintainability, readability, and we take that hit. We don't care. But if you're writing a systems program, you do care. So this is valid Rust code. What Rust is going to do under the hood is take map, filter, and fold. Instead of doing those 3 iterations, it's actually going to create like a single loop and actually do all that work in a single pass-through of 10 iterations. It'll actually inline map, filter, and fold and sort of do that in sort of one shot. And so you don't need to worry about it. Like if you want to write your code expressive and make it really clear what's going on, you don't have to go back later when you want to optimize it and sort of make it almost unreadable. Has anyone ever looked at the OpenSSL code base before? Like you wonder why there are so many bugs in that thing, right? They're trying to make the thing fast. And when they do that, it becomes almost unintelligible what's going on. Here, we can make it really clear what's going on, yet still get all the performance out of it.
Could you add more methods like that as a user of the language that like kind of inline together like that?
The question is, can you add sort of methods like this as a user of the language? So the nice thing about Rust is Rust is written in Rust, and these are just iterators. So you can write your own iterator methods and sort of do this yourself, and people do this all the time. Other question? Yeah, sure. The question was, why does filter take a reference instead of the actual type? The reason why filter takes a reference is it doesn't actually need to own the variable to it just basically needs to sort of use the variable to check something real quick. Unlike map, map might actually mutate the variable. Filter is just sort of peering into it, so you don't actually take the variable. You just take a reference to the variable. And that's common like in the generic filter method, right? So these are all like immutable things. So you can make map take a reference if you really wanted to. Other questions? And then we can even go one step further where Rust really does have first-class functions, like a JavaScript type language, right? I wrote some code. I created a simple REPL, read, evaluate, print loop for Rust. And this is what my main function looked like. Again, systems language, where our read, evaluate, and print are all functions. And again, the compiler using LLVM compiles this down, and we're taking no performance hit. And we're getting sort of all the monadic stuff going on here with the and thens. We have all the expressiveness, like it's very easy to see what I'm doing here, and all the speed of C. Let's go one step further with generics. If I define a function here first, and if you're familiar with like Java or anything like that, we're defining a generic type A and a generic type B, and creating a tuple out of those values. And we're basically just saying like it's going to return that type A. In the body of our function, we're just saying for that tuple, just return the first one. So that's what the function's doing, right? Very simple. Most languages have to do this at runtime, right? Like if you do this in Java, Java is actually figuring out at runtime like how to actually like figure out all the typing stuff. And you can run into some problems there where it can actually not figure it out. So for Rust, we can do the same thing like you can with any other generics. We pass in integers, you can pass in strings. And even when we do this in something like Ruby or PHP or Python, it's doing this at runtime. We just never see it. It's a hidden cost, right? Actually, what Rust does is it has this concept of monomorphization. Long word, don't have to remember it. But essentially what this does is the compiler creates a specialized function at compile time for sort of each type, right? So if we're passing in if we're passing in an integer, the compiler goes, oh, I see you're passing in integers in your program. I'm going to go and create a specialized function for integers. If you're passing in a string, it's like, I can see you're passing in strings as well. I'm going to create a specialized function for strings. That can look basically like this. Like, you could do this yourself too, right? You can write specialized functions. Rust does this for you for free. So you don't have to actually, you can write really generic code. We saw with our closure example earlier. And under the hood, it's creating these specialized functions for you that you don't have to manage. It's just like, I got this for you. So again, all the expressiveness of sort of a higher order language with none of the sort of the performance cost. Is there a question? And this, the question was, could you have a string and a numeric? I am defining two discrete generic types, so you could. I didn't show that example, but yes, you can kind of do any sort of generic stuff, typing that you want. Great. And then let's move into another topic here. So systems programming, we might think if you want to become a systems programmer or write a systems program, you got to write the entire thing in sort of that language, right? It all has to be in C or all Rust or all C++. And actually, I would argue systems programming doesn't sort of, the definition doesn't actually require that. What we can actually do still is write the bulk of our program in something like Ruby. And then once like we're done writing that program, we can actually go back and figure, like, is there any like really slow bottlenecks that are not I/O bound? Any CPU bottlenecks? And if there are, we can actually drop Rust in to actually solve that problem. I actually did this. There's a library out there called Selecta, which was written by Gary Bernhardt, which is a really nice sort of little command line utility that allows you to quickly search your file system for things. It's really nicely written and had like a full TTY and all this support. But there was this one hotspot in the code where there's this really efficient search algorithm, but because it was Ruby, it just could never run fast enough. It was always like the biggest bottleneck in the code. I actually just took that library, rewrote the search algorithm in Rust, and put it back in, compiled it into the overall program in Ruby, so Ruby could just call my Rust code. And we can do this because Rust treats C as sort of the common language across the entire ecosystem, which is basically true, right? And Rust interacts with C really well. I'm not showing an example here because it's a fair amount of code to get it going, but there are a lot of examples of this on the web. On my blog post, I have one for PHP. Again, I've written one for Ruby. It's fairly approachable. There's some, obviously there's like some boilerplate work to sort of tie into those C interfaces that are sort of defined. But Rust makes it pretty easy, and because you have all that fine-grained control. Rust isn't like a GC language, right? If you try to do this in something like Go, which Go is a great language, but Go has a GC in it. And if you're trying to match Go's GC up to Ruby's GC, what do you think is going to happen? Like, not good things. Because Rust doesn't have a GC, just like C or C++, you can easily tie into this. Even Node. So what recently came out, too, was an example from someone at the, I remember his name now, at Mozilla actually put a whole blog post about how you could actually tie Rust into the Node.js runtime, which is written in C++. A little bit harder than C. Let's see here. So I went over a lot of concepts. It's really hard to sort of go through some of the code examples here, but there's a lot of sort of ways you can sort of start digging into Rust. I don't think there's actually a Rust book out yet, but the documentation on the website is great. Steve Klabnik has done a great job. He's actually employed at Mozilla and does that full time. But I actually think an even better way to learn Rust is to come to the Rust Los Angeles meetup. I actually run that meetup. And we do things like last month, there's a new program out there called Stockfighter. If anyone's heard of Stockfighter before. And it's basically a game where you write an automated stock trading program. And it's pretty real. It's not 100% real, but it's pretty real. And believe it or not, no one had written a Rust SDK for it, so we're writing a Rust SDK. And really, I think the hardest thing about, with any of this stuff is getting started, right? Rust lowers that barrier to entry to get started a lot, but there's always sort of something that doesn't make sense. And so if you're with a bunch of other people, those questions get answered really quickly, and you actually feel like you're making a lot of progress. There's the website on there. And again, reach out to me if you have any questions. That link at the bottom is a link to all my blog posts on Rusts, and there's actually a number of them on strings. So if you do start writing Rust and strings are frustrating you, go ahead and check those out. It should make things a lot more clear. But feel free to hit me up on Twitter or GitHub or anything if you have questions as well. And with that, I'll open the floor.
When I said the website, what I meant is Rust can be a very easy choice when you have a very small device, which is what I'm interested in. Do I have some way in which at least I can generate a Rust executable for an Arduino compatible with AVR8 or some other small controller?
Yeah, you can. There's actually, the question was, can you generate a Rust program for something like Arduino? Rust recently in 1.6, which just came out, actually has stable support for not including even the standard library of Rust, only just like the bare of the core components, which allows you to compile it for things like the Raspberry Pi or Arduino. And basically, the footprint's very light. You get just the bare bones. And then it is. I realize that. You still can do it for the Arduino. The Rust compiler has compiler targets, and you have fine-grained control over the different compiler flags that you can send and make, and you can sort of compile it to anything you compile C to. The question was how small is the Rust binary be? Yeah, so Rust Hello World is a little bit larger than you might think because, again, it's doing a lot of that sort of specialization under the hood. Again, if you need to optimize something, you can do it unsafe. I don't remember off the top of my head, but I know it's a fairly large Hello World. They have not tried to optimize for the Hello World example. I know some people have been interested in that, but it's kind of a red herring. I think once you get into something that's beyond just a simple program, it sort of gets amortized out, and you're basically sort of on par with C or C++.
You can make something that goes on the 50K.
Don't quote me on that. You could certainly ask on the Rust users forum, and they would be able to give you some direct examples. I think there's been some talk about that. So I'm not into that space as much, so I'm sorry I can't answer like definitively. Yeah. But certainly it's of a lot of interest to the Rust community, embedded programming, stuff like that. Other questions? Joel, and then...
So you mentioned that OpenSSL in particular is a complicated software. Do you see someone taking up Rust to do actual security for crypto software?
There is a Rust libraries or user libraries in Rust are called crates. There is a Rust crate that's starting to replace parts of OpenSSL. I think, Rust is 36 weeks stable. It went through 8 years of basically prototyping to solve that main core use case of Servo. So we've been 36 weeks in production mode, like a 1.0 release, and we're in 1.6 now. And I think really the community is sort of looking at things that form like a 10-year frame of reference. So I think we'll see more adoption of those things as they come. But sort of things are kind of going slow as we're sort of figuring out things like higher kind of types. I think as we sort of figure out more and more things within the community, you're going to see more adoption and see things like an OpenSSL port to Rust or other things like that. I myself do a lot of work with a library called Mio, which is a replacement for libuv. So it uses things like equal or KQ if you're on BSD. It's a complete Rust replacement for libuv. That is, I think Dropbox just put out. That's what they use to sort of create their hard drive mesh and to figure out how to load balance all those different files across your system. So it's coming, and some people are really interested in doing that because it's nice to write in. So, yeah. Your question?
Can you talk a lot about concurrency control in Rust?
So the question was, can we talk about concurrency control in Rust? Yeah, I would have to dedicate 10 slides, I think, sort of to walk through just how that sort of works under the hood. There are some examples up, but essentially, Rust is using the borrow checker, and you can sort of reason about how you're allowing threaded computing to share memory via the borrow checker. And so it does that all at compile time. So it's using those same semantics to sort of enforce that you're not going to step on a piece of memory. So once one thread takes ownership of a piece of data, the other thread just can't. You don't need semaphores or mutex at that point, right? They are, and then you can actually use a lot of other semantics out, like when things get freed up or out of scope, to pass back ownership upstream to a different thread. So like there's a really good way you can like do that with channels, for example. It makes it really easy.
Is that better than Go?
So the question was, is that better than Go? So Go is focused more like on their like Go routines, right? And they do have channels and stuff. I believe the last time I checked, the Go routines actually leak a little bit of memory in order to do a lot of their safety guarantees. So again, Go's a great language. I think it's has a lot of use cases. I think to replace a lot of Java stuff for like web servicey. It's like kind of lighter weight than Java. I think that's where it really shines. And again, you don't really care about if there's a little bit of leakage there, right? But there are coroutines in Rust. You could do the same thing, but they just sort of have different strategies. Again, Go has the garbage collector. Yeah. Other questions? Here, and then we'll go back to you. When is the next Rust? Yes, the question was, when is the next Rust meetup and where do we meet? The meetups are usually in the middle of the month, so it's whatever that Wednesday in the middle of the month is when we meet. And we meet in the Nordstrom Rack / Hotlook production studios in Culver City. And if you go, the website has like a huge thing of directions, so you can get there. But yeah, check out the website, has all of that information. Hope to see you there. Question?
How do you see Swift affecting the acceptance of Rust?
Yeah, so competition's good. I actually don't think it's really going to impede it too much. We've even seen like in C++, a lot of stuff that we've been doing in Rust, the C++ community has been trying to do to like take on as well. And there's actually now some sort of certain pointer types that sort of have some kind of ownership and properties that Rust has been sort of messing around with, right? If they're already like things like own pointers in C++. I think Swift is going to sort of make it more, make things more accessible. You're going to get a lot of people who were writing iOS apps, starting to write actual server-side stuff like in the OS X ecosystem. So I think actually it might only speed up adoption of something like Rust. They have a lot of similarities, but they also have a number of differences too. That the Swift community said, like, we're not trying to compete at that level, or that's sort of some of the we're compete in some of the areas where Rust is trying to compete. Another question.
Yeah, do you feel my experience with other developers is that a lot of people tend to struggle with functional language. Do you feel that's a restriction for a lot of developers? Especially because you're introducing this to mostly web developers here, which they're programming PHP and Python, and not a lot of it really focuses on functional language, but Rust is primarily a functional language. How do you feel?
So the question is, if the difficulty of functional language semantics would be a blocker for the adoption of Rust. So Rust actually is an expressive language, not a functional language. So it actually can do a lot of functional things that you find in other languages. But every single thing that you do in Rust is an expression. What I mean by that is you can actually assign a variable to the result of an if statement, which is actually after a while quite natural. So you can write your code in Rust in the most basic imperative form that possible, just straight like almost in that classic C style, right? Which is a bunch of functions, and that you just sort of cobble it all together and make a program out of it. So again, a lot of the stuff that we talked about is opt-in. You don't have to take advantage of like map and filter and fold if you don't want to. You can actually just write just normal functions and it'll work just the same. So I actually don't think that's too big of a deal. I think it's really more of an upsell that it can do those things. I think most people sort of want sort of a higher order feel to the languages they're working in now. Question? The question was, does Rust have exception handling? So Rust does not have exceptions. It does have a macro called try, which at first glance might look like throw in deal with exceptions. That's just bubbling up things like options or result types. But the language designers made an explicit decision not to sort of add exceptions into the language. Panic, and though the things look like exceptions as well, like they'll sort of quickly abort the program. But yeah, I don't think there's any plans for exceptions in the language as well. That's sort of a hotly debated topic, but that was the decision. Any other questions? All right, well, thank you so much for listening to the talk. I hope to see you at the meetup. Yeah, 4 minutes. How's it going? I think Python's great also because, like I said, it might be the best strategy to write. And then either more experience in Python or Rust doesn't really need it. Like, for example, Memcache is going to Perl. And you wrote the so you can kind of use that same strategy. You have to kind of do like a rewrite, right? You can really write a portion of it in Rust. I think some people, like myself, like I can be as Rust as I can. So I'll do that out the gate. But it's not a deal very tough to sort of really make your progress. Also sort of really thinking of like the bottom. So if you're trying to figure it faster and using it like at work, feather it in small pieces. Yeah, Rust actually has Hyper is one of the web frameworks that has it's actually one of the really good libraries to it. Like it's actually much better than So yeah, I actually will block those. I should have done this wrong. Yes, right. Yes, right. Yeah. There's a hole you are going over. It's always nice to be appreciated, rarely. I'm assuming, of course.
sounded interesting, actually, but I'm tired, and this is probably going to be really awesome. Yeah. Yeah. Well, and I was telling Nick, I'm pretty tired at this point. I probably won't bring much of it. That's how you use it. That's pretty good. You should not.
Why shell shock? Things that come in from honestly, I'm like, all I gotta do is make the course talk, eat, and then take out. That's my goal. Like, eat. Yeah. No, I took a nap. That's why I'm sleeping. Because I went and took my 2-hour nap. Yeah.
Yeah, it's 7 hours back there.
No, I didn't know that. Yeah.
I also had like 1,000 pounds of syrup here in my trunk. Oh, and was going the speed limit while I was in.
Yeah.
You'd be forced to drive the speed limit until you cross it.
Thank you. We need security staff.
It's like,
This is surprisingly full. I'm plugged in, ready, good to go, assuming the projector works.
all right.
Fair enough, I'll continue mucking about with it.
No, they should sit down. I mean, they do.
I love that.
You know, you're a California native.
All right.
They won't let you go 5 over without any trouble.
But if you're not from there,
They won't let you go even 2 miles an hour.
exactly. Like, they'll put you that way.
Oh, it comes up later. You saw nothing.
I've learned my lesson. I've spent enough time.
Stick around. Stick around.
And at the end, so now they're like, like, we don't care. Yeah. No explanation. Like, even like, I think if you're taking up the you can't
Yeah, CHP is always kind of easy.
they automated a lot of it too, actually, like,
Oh, yeah. Half between your wallet and our state's coffers.
that's actually it's an impressive state. Which sucks because they're it hurts when
Like a 5-speed like here. I know.
I almost got another one like and I mean they have cameras.
Yes, you got 2 choices. You can
No, that's fair. My dad does the same thing. He's like, are you even home? Yeah. All right.
As fast as you can.
You're a gentleman and a scholar. Last presenter. Sure, we can do that. Best thing to do is turn it on. Let's see, does that work? Cool. It's always fun when presenters use an audio. No, thank you. I believe I have enough. Like, everybody for example, like, if I buy a drone, to register it.
Well, you're open airspace at that point. You absolutely have to register. Especially when these things have a pretty high altitude on them.
Yeah.
Like higher than you can see. No, not the drone. Their radio links are.
Oh, no, mine, the one that I want. It's kind of and then if you go into
Oh, yes.
go over that room.
Well, so pretend that I'm talking right now. Like a normal civil airspace.
Oh, absolutely.
So you make it 15,000 you're into commercial airspace. So yeah, you can absolutely. Oh, right. For this. I'm surprised they don't make you also have an IFF transponder out as well.
Alternate with this. I'm hoping it doesn't get so wonderful. All the photos that have been on
And not only that, they have cash to go live.
they give it a good song.
They're going to be deploying their own stuff.
Yeah, we're good here. I'm ready if you are. I do want to verify that the full screen terminal is the right side when we dive into it. Is there a central location to change that? Okay, you know, they do here. Because right now it's showing. Plug in. Recording.
expecting another display somewhere. It turns blank. It then comes back. And it tells me there's another display attached. Sure, we can do that. No audio needed. There we go. Good. What, I get to introduce myself? Oh, turn this on, shouldn't I? Hey.
This is the last talk of the SCaLE. Terrible ideas you get.
All right, thank you all for staying as long as you have. This talk is something that I put together that fell out of a class that I taught once called The Screaming Horrors of JIT. JIT for Systems Administrators. No, I'm not going to pronounce it JIT the entire time. Right now, I head up the DevOps group over at Future Advisor up in San Francisco, recently acquired by BlackRock. It's fun, it's exciting. Please apply, we'd love to have you. Okay, obligatory hiring pitch aside, we have a lot to talk about. Feel free to tweet at me. If you have any questions, throw a hand up. We'll go from there. All right, let's get started. Okay, I'm going to start with a promise here that everyone is going to learn something here today. I don't care who you are. If you're one of the Git authors and you're sitting in the audience, you're about to learn exactly how I mistreat your baby. And one thing that I want to point out here, I have a bit of a reputation for building talks around me making fun of things, and this talk is no exception. The difference is that every stupid thing that I'm about to list in this entire presentation is something I've done inadvertently. So, if you can't laugh at yourself, who can you laugh at? So, there's no shame in coming and admitting that you can't necessarily do something. Okay, so let's start at the very beginning. Who here uses Git? That's an impressive showing. Who here wishes they used Git? Who here is just raising their hand because they're staring at their phone and want to pretend they're paying attention? Good. Okay, at its heart, Git is extremely simple. It tracks files, it changes to files and directories over time. It lets us collaborate with each other and share those changes back and forth. Lets us work on teams that are distributed, both in distance and in time. But it's extremely simple, which is why in these talks, the next slide invariably looks something like this. Because, let's face it, there's an elephant in the room when it comes to Git, so let's introduce it. It doesn't matter who you are. Eventually, Git leaves you feeling like a moron. It gets very deep very quickly, and the only question is how long you can hold on for the ride before you've gone off the deep end. And it seems like there should be some reason behind it. Why does Git get this complex? Well, apropos of nothing, Git was written by Linus Torvalds, who is famous for three things primarily. Yes?
Did you know he named it after himself?
He did indeed. He names all his projects after himself. We'll see what the third one turns into. But in any case, at this point in time, Linus Torvalds is famous for three things. Writing Git, which is why you all are presumably sitting in this room. Creating Linux, which is why everyone attends this conference and why everyone in this room more or less has a job. And for tearing people to pieces on mailing lists. So, yeah. So Git, despite its complexity, Git does let you do some incredibly powerful things. Powerful, of course, being a euphemism for stupid. You can commit large binaries to Git. You can commit atrocities in Git. There we go. Now, Git tends to operate in a relatively, sorry, we should probably build a repository first, shouldn't we? What an amazing concept, the demo gods. Git init. Now, local operations on Git are really fast. So when it hangs like that for a little bit, that's your first indication that something might not be quite right. Yeah. I'm not as much of a genius as I thought I am. Okay. So now we see that in addition to committing an ISO, we have built out the .git subdirectory that tracks all of the changes that go on in here. And if we take a quick look at that directory, it's now 69 megabytes, which is a totally reasonable thing to stuff into a Docker container, but that's neither here nor there. So, okay, I've done something stupid. I've committed a large binary to Git. That's okay. Okay. Now, if I do a git status, it tells me the file is on track. It's no longer being watched by the Git repository. Huzzah! But notice we still have a 69 megabyte .git repository. Changes in the past, things that have been committed to the repository, stay there forever. It's awesome. Yeah. So the way we're not often committing large binaries to Git, but when we do and we want to fix it, in order to unwind this, you've really got two options. You've got a relatively complex command called git filter branch, which you can wind up going through and removing all references to it, and then you wind up having everyone else realize, hey, there's a mismatch between what you think you have and what the server used to have. You're rewriting history when you do that, which is bad. Or you can use a Java tool called BFG, which will go through and tear through things. It takes a little bit of time, and it's annoying. Now, here in the real world, if you want to go ahead and store large binaries in version control, look into two different projects. They're designed to solve this problem, and they do it a lot more effectively. Git Annex was written by Joey Hess, a former Debian developer, and GitHub wrote Git LFS, which they are pushing harder and harder all the time. Now, most of us aren't going to be spending time committing binaries into Git, at least after the first time we do it and get yelled at by management. But we're often committing things that we shouldn't be, like secrets. Replace large binary with private key for an API key for Amazon or an SSL certificate or a password, and you begin to see the problem. Now, at Future Advisor, we are committing secrets into Git. We're just encrypting them with GPG first, and then using Salt's renderer, the GPG renderer for SaltStack to wind up turning those back into plain text. That's a sensible and reasonable way to get to work with it. But remember, you can go back in time. Just because it's not in the current revision doesn't mean it's not there somewhere in the past. There are stories that abound of people exploiting systems by doing deep dive searches on GitHub and back on Google Code when that was a thing. Let's move on to another terrible idea. I don't even know how to describe this. Let's just go ahead and show you. There we go. That's how we learn to type. So, remember how I said Git can make anyone's head hurt? So, Git init. It creates a .git repository. If we take a look inside, we have different things that point to the latest commit. It keeps track of different branches. There's a local repository-specific Git config. The usual things here. But these are all files that wind up controlling what a Git repository does. Well, these are files. I care what happens to them. I should probably track them in something. The sad thing is that this works, and you can go deeper. If you're ever doing a find and things like this hierarchy turn up, something very wrong has happened. Okay, on a topic here. Let's take a look now. And have you ever done this? You start typing a command like git status, for example. And then you have to turn away and look somewhere else to actually copy the repository or whatever it is you're looking. Then you come back. Git status. And there it is. Git's telling you you're a moron. There are ways to fix this. Now, what's in that file? Very simple, just git $ampersand. Sorry, $@. Good Lord. You can tell I'm losing it. And it winds up working really well. You can now git status. But wait, there's more. And it works. Something very similar to this will make Docker a reality. It is turtles all the way down. Okay. So Git does have its own alias support. You can build Git aliases. But that doesn't always tend to go quite far enough. Because for starters, you have to preface all of them with Git. So if we don't want to do that, we can back out into the shell and wrap shell aliases around lengthy and extensive Git commands. For example, now, why in the world would I want to do this? Hope I do this in the right place. There we are. Remember, you accepted this talk. So, the power of doing things with Git is that it opens new frontiers in being a jerk to the people you work with. I really feel like this should be on GitHub's marketing page. They can have the slogan, I'll license it via Creative Commons. So, we've all heard about rebasing master. What that effectively does is it goes back and changes history. So everyone working on a repository suddenly doesn't have the history and the thing they're working on that they thought they did. It changes history so everyone else gets screwed. If you see a group of ravens, they're called a murder. A group of whales is called a pod, not a docker. Thank you. A group of developers is called a merge conflict. Now, I'm not a developer. Big surprise there. I work in operations, and I don't have time for this. So I use this. It's a lot simpler. Hey, DevOps? Nope, we're just the department of no. It's easier. Okay. So we've shown that Git can make us feel stupid. Why don't we let Git help us feel a little bit smarter? I really wish there was a better way on a Mac to transition more elegantly than that. Okay. Ever typo something like that? And then Git tells you, hey, jackhole, didn't you mean this other thing? Well, there's a way to fix that. Now, what that command does, and I'll break that down for you in a second, is actually kind of helpful, except for the part where it can screw you if you're not careful. But that's computers, right? This is more or less a type what I mean, not what I say thing. Now, what this is we're setting a git config option. Note the -- global. As a small detour, there are 3 places that git config will alter things. Globally, which winds up doing this in your users.gitconfig in your home directory. The system level, which is an etc git config, which is a really great way to confuse anyone else on that system. Or by default, in the repository itself. And so that's kind of awesome. What the help.autocorrect does is it says, go ahead and if there's only one right answer that you think I'm trying to type, go ahead and use it. Now what the 8 does is that is the number of tenths of a second it will wait for you to hit Control-C before saying, screw it, I'm going anyway. We sometimes call that the penalty of having to wait because you typoed something. Set that high enough and you can make it really painful. It's kind of awesome. But it doesn't work on everything because this winds up only working when there's one right answer, and it's not as smart as you would like it to be. For example, how many times have you tried this? So you add a remote repo, things are great. You want to push to where it's going, and it tells you that no, if you want to push it to the same name branch upstream, you have to explicitly tell me. And it's frustrating. Fuck. And then it works. And it works again. This is a program that's been making the rounds. It's on GitHub. Most notably, more than any other technical thing that they have done, they have managed to get the first Google result when you Google the phrase, the fuck. That's amazing. Okay. So, humor aside, I do have 3 legitimately useful tools that I want to talk to you about today, and they do tend to play rather nicely with each other. So, who here views management as perpetually looking for something shiny, like a moderately intelligent squirrel? I see a few hands, including some people who work for me. That's good, good, good. As a manager myself, I have to say you're not far from wrong. So, when I first started at my current employer about 6 months ago, they didn't really have anything resembling a monitoring system, and we fixed that. But while it was coming up, we had a big monitoring board next to my cubicle that was dark. So what I wound up putting up there instead was something very similar to this. If we can go ahead and get that to... It's a program called Gorse. There we go. And what that does is it lives in a Git repository. You run in a Git repository. It's an open source software program. It lives in just about every different type of, in any type of package management system you've got for every operating system. And what it does is it provides a visualization around every bit of history that happened in that repository. So we would see fun things like our CEO way back in the day going ahead and making some changes. And then our founding engineer would go in and immediately revert all of them. And it was a great way of looking at where we had come from, where we've been, where we're going. And once we replaced it with a monitoring board, people didn't come by and look anymore because they would just like to come and tell stories and marvel at the history of what we have done. So that was kind of nice. Don't ever doubt the power of being able to show something shiny, even if it's not as informative as you would hope. G-O-U-R-C-E. It'll be on the board at the end, a link to all the tools I'm talking about. So, does anyone have more than one Git repository that they care about? Unless you work at Facebook 2 years ago, your brand's probably up. They were famous for having a single monolithic repo. And it sucks, because when you have 15 or 20 different repositories that you care about, and you get on a plane and you realize you're missing the latest changes to that one repository that you really need in order to get something done, like put your slides together for a conference talk. So Mark Atwood posted a decent fix here. Specifically, you just punch a find command into a for loop to find Git repositories, iterate over it, you fetch the latest changes in every repository's parent, and I would think half of you just fell asleep. So this is really awesome, except for the part where it's shitty. Because I'm going to do this once, but I'm not going to go ahead and run this every time. So I tweeted back at him. So I took his stupid loop, but instead of just running a git fetch, I ran a different command. In this case, mr register. And then I don't have to remember it anymore. And he tweeted back, "This is awesome, thanks." And the point here is that we're always learning. Mark is the director of open source at HP, maybe HP Enterprise now. I haven't been keeping up with the various changes. And this is a guy who's forgotten more about software than I'll ever know. We're still always learning about this one weird trick that no one has pointed out to us before. We're also usually not the first person to encounter a particular problem. So when you start realizing this is annoying, there's probably a better way, ask people. So let's talk about what MR is and does. It used to be called MR, and this in the tradition of open source projects of having a name that's virtually impossible to Google. And then they said, this is actually a really handy tool. Maybe we should change the name, which makes it easier to find, but now I never know which is the proper name, and I invariably use the wrong thing. They've managed to take one of the hard problems in computer science of naming things and made it worse. So, step one is you run mr register inside of each repository you care about. You can do it by hand. You can do it using a for loop like the one that was on the board a few minutes ago. And it doesn't really matter, because you only have to do this part of it once. It goes ahead and it builds out a file called .mrconfig, the typical Unix fashion, one of your dot files. Then you go ahead and run mr update and watch as it updates your repositories. Specifically, I give it mr list. It spits out a lot of things that didn't show up because of the weird resolution on this. Right then. Then I tell it to mr up, which, if the conference Wi-Fi behaves, no guess, there we go. It starts in series updating each and every one of the repositories that I care about. If I take a look at my mrconfig itself, note that there's an include there at the very top. There. Note the include at the very top, where I'm including my entire my mrconfig directory, which means I can drop individual files into there. So if I have, let's say, something for the front-end team, and there's a list of repositories they need, I can build an MR file and just pass it out to them. They can wind up using this. I also, if you take a look at specific environments, for example, you take a look at Puppet or Salt, you see a bunch of different repositories that in turn wind up being given specific instructions of where the parent lives. Yeah, MR is not, the list is not working well with Tmux at the moment, but it spits out 30 different repositories, which is really the relevant part of it. You can also break this down into groupings by going into subdirectories. If I go into my workspace directory, into an MR list again, and type it properly, in turn it breaks it down to 12. I've never seen it do this. There's something strange with the projector. Anyway. So at this point, that winds up letting you sub-target among different groups. There is a slight movement toward getting actual better grouping logic handled in this, but it hasn't gone anywhere yet. Patch is welcome. And it's not just working with Git. It works with virtually every version control system that you can think of. The notable exception that's not on this list is Perforce. But patches are welcome, which in the open source community is how we say, go away, Git, you bother me. I mentioned how we can limit operations by using a sane directory structure. I tend to like hierarchies for things like that, where I'll have a front-end directory where I just have those work repositories, and a back-end directory, and they both live in a work directory, so I can just go drill down a lot more effectively. Now, I wouldn't know that this tool existed if someone hadn't told me about it. And that's really what part of the community aspect of open source comes down to. A stodgy German friend told me that it existed. I thought, this is ridiculous. Why would I ever use it? Oh my God, that's kind of amazing. Now, I bag on them a lot for this, but Docker absolutely nails this. You can't get people to stop talking about Docker, and that's kind of fantastic. Anyway, my crazy German friend told me about this in conjunction with a tool he himself had written called VCSH. This is effectively a version control system that built on top of Git for your home directories. Who here has a global .files repository where they keep their things like .zsh or .bashrc, their .vimrc? Right. It's a common thing, and it usually looks a lot like this. There's countless numbers of them on GitHub, and it's fine, but there are aspects of this model that are kind of crappy. I don't want the Git repo that has my personal AWS credentials in it. Yeah, I know, I keep those in Git. I still do terrible things. On my work machine. And vice versa. I don't want my work credentials from a Git repository living on my personal machine because that's a great way to get fired and sued. So what I do instead is use something called VCSH. Okay. Yeah, the listing function in this works at least. Okay, what it does is it lists out a different series of repositories that are controlled in this. Let's, for example, take my git config as a great example. I run this, it then winds up instantiating a shell session underneath where I am now, and if I take a look at where I am, I'm still in my home directory. I haven't changed anything about that. But it does take advantage of how Git works internally to wind up with a Git root that lives somewhere else. And if I do a git status, my .git config has been modified. But there have been all kinds of file changes in my my home directory that are not being picked up. The reason that happens is if I can't .git ignore, I have a wildcard in it. What this means is that in each repository, I do need to explicitly force add any file that I want it to track over time. That's a little bit of a hurdle, but it winds up paying for itself later in time. The idea is then I have my git config living in a completely separate repository from my SSH config, and neither one of them know anything about each other. I can make my changes. And we're back up and ready to go. Then I hit Control D to log back out, and I'm right back where I started in my home directory. I run git status now, and it doesn't see it as being in a Git repository, which is handy. It helps avoid the submodule problem, among other things. So what this does under the hood is you have your home directory. You have your home directory, and right under that you have a .config directory. This is stolen from some of the Debian people. They tend to like this particular approach to things. I'm lukewarm on it myself, but it works. The idea being that we then wind up spreading things out. So you have a list of things that are available that VCSH can manage, and you can pull these with MR, which is typically how you would handle this. And the ones you want on this machine, you quite simply have a symlink in your config.d directory that wind up pointing back to the original source of the repository. So you can effectively turn repositories on and off with this. Therefore, because I've never pulled things except for what's linked in config.d, while I know where those other repositories live, I never have their data locally. Then, in turn, when I wind up checking out the repository, it does under the VCSH subdirectory in repo.d, which then is where that repository actually lives, but checks out its files into my home directory. I have one more trick that I do want to show you that has been extremely handy as I've gone through Git. A lot of people have something that does this already, but a surprising number don't, so I'm going to point this out. Now, you've been seeing it throughout the entire presentation, but I haven't called attention to it. It tells me what, you'll notice that next to my prompt and the ridiculous Dockerized host name that's a hex character that winds up being populated, it tells me that I'm on my Git master branch, and there's a red 1 with a dot next to it. Now, what that tells me is that there's a file that's been modified and has been added to Git staging area, but has not yet been committed. So I go ahead and I make that commit. Now my prompt has changed. And you'll see that it still has a green check mark, which tells me that things are decent, but I still have a commit that needs to be pushed up. Notice the one with the arrow, with the up arrow next to it. It tells me that, Git status tells me that I'm ahead of origin master by 1 commit. Use git push to publish those commits. What having that in my prompt does is twofold. One, I have to type git status a whole lot less. And two, it gives me a constant subtle reminder of maybe I'm not on the branch that I think I'm on. If I'm about to make a commit to a feature branch and I see the word master there, that should set off a quiet alarm bell in my mind. Now, increasingly, since I first built the original version of this talk, GitHub and others have made it harder to forcibly push changes to master if you disallow it on a particular repository, which is great. But not everyone enables that. Not everyone can enable that due to various workflows. And ultimately, it tends to not be particularly a panacea, which is why I do like having that subtle visual clue. So here's a link at this point to everything that I mentioned today. And I'm going to leave that up there for people to take pictures of, jot down, while I answer any questions you folks may have. I keep thinking they're hands raising, but nope, just pictures. There we go. Hey, a hand. Unless there's a camera in it. What's up?
What graphical interface do you use to manage your Git repositories?
Great. To repeat the question, I was asked what graphical interface I use to manage Git repositories. I have come from a sysadmin background. I use the Git command line client, and that's it. Other people like things like Tower. Some people like, I think Git K is in somewhat frequent use. But personally, I've never made the leap into using a graphical client for it. That's mostly preference at this point. From my point of view, I can always drop into the command line tool. If I can solve that, then what the graphical elements do don't necessarily matter. I do understand that's a highly opinionated perspective for me to have, but unfortunately, I'm the wrong person to ask. Anyone have something they use for a graphical client they love?
Atlassian has one that they make available for free. I don't know if it's open source, but they've got one that's pretty good. I can't.
Yeah, I remember Atlassian did have something. I don't know. What is it? SourceTree? Yes. I think someone at the office might use that, but I wouldn't swear to it. Sorry? Magic? Okay. Fugitive. Oh, well. Vim Fugitive. Yes. Yes. Yeah, you could do that too.
Not quite a GUI, but TIG, curses-based client for Git.
Yeah. Ultimately, this is one of those things we can wind up, you can take a survey of a room like this and wind up and spend the next 20 minutes listing things on a board. There's a lot of answers in that space. Find something that works. If that's the direction you want to go in, I'd suggest finding something that works for you. Try them out. Most of these things are free. Of course. Other questions, comments, concerns, criticisms, snark. Hit me with it.
I feel I was promised that I using it, and then this is all helpful.
Well, you know one of my favorite things to do in the open source community is disappoint people. It feels like I'm standing through a room full of my dad. It's great. The Hobson's choice I was given was submodules or subtrees. I really don't like either of those. Submodules are annoying specifically because it's not always obvious what they're doing and how they work. Subtrees are supposedly the better way of doing things. Personally, I avoid it with things like VCSH, which if you leverage it correctly and move it away from just a home directory, you can use something like that that works a bit more effectively. But it's one of those awkward questions that everyone hems and haws when you ask them because there really isn't a good answer to that. For those who aren't familiar, what submodules are is you put a Git repository inside of another Git repository, not in the crazy way that I did inside of .git, but if I go down a level and then create more repositories, how do you wind up keeping the parent repository informed of the changes in the child? Other questions, concerns, snark?
What was the config that you used to show the master, and how many files were available?
Yes, what I use for that is something called ZSH. It's a ZSH specific plugin, which I'm noticing not as many people are using as down here as they are up north. So I tend to not necessarily call that one out specifically. Some people love Powerline for that. Other people use Airline, and there are a few more that go along with that similar naming convention. I'm sorry? Bullet Train? Yeah, that's one of those situations, again, where there's 50 different answers to that question. But again, the way I picked the one I found was I just started playing around with it one day and moved through a series of different ones that I found one I liked. If you're using ZSH, feel free to tweet at me. My Twitter handle's on the next slide. And I will go ahead and dig out the one that I'm using and get an answer for you. Other questions, concerns? You again.
So you're using are there valid reasons for not using? Because I have found them.
Good question. A little off topic, but are there valid reasons not to use ZSH? Well, again, the same reason I don't use a GUI for Git is because I spend a lot of time logging into systems that are not directly in front of me. And in order for me to use things that I'm comfortable with, I should at least understand Bash. So it mostly comes down to portability. If nothing else, Bash is everywhere. ZSH is not. Other questions, concerns, snark? Perfect. Thank you all for coming. Thank you, sir. I appreciate that.
You are the only other person I've seen that knows anything about this. I wrote an article like 4 years ago.
Yeah, I introduced you to the guy that wrote it.
Yeah.
Richie H. He's still doing well, apparently. I should probably take that.
I'm just like, oh my god, I know what he's doing. It's so powerful, no one knows about it.
Right, that's why I throw it in talks like this. Unfortunately, I'm having trouble finding good ways to make that part of it snarky.
The problem, you showed how to use it way more eloquently than I could in print.
Yeah.
It's hard to describe in print.
Yeah, it's hard to describe regardless. I went through 5 or 6 different machinations of how I would structure that before I came up with this.
It's good.
Do you guys ever play with the Git tool for interfacing with other repositories?
Very likely. I did a couple of result engagements of converting between portable things, but as far as running like that day to day, it seems a little challenging. I do hear good things about Git-P4, but I don't have a perfect.
Well, I did that. But it's not good, like, SCaLE.
That could be some big hours or something. It came out figured out.
Yeah, the platform I was using, it was really, I know it wasn't
biggest challenge of people not using Git is that they wind up migrating between different environments where there's so much legacy stuff. Like, our company's 5 years old. We started with SVN, so we had to do a massive migration around.
And now will the
There was something we were missing.
the MRVCSA will that allow you to like sync repos or branch from one repo or branch to each other so that you can make changes to all of them and then transmit?
We're also doing branches. That's something that I don't work with. Generally speaking, I'm not sure how it would work. You've got, theoretically, you might have having the same file track by 2 repositories, but as soon as you change it in one, the other one's going to say on track change. Either committed or not. It's not going to change.
That's one of the kind of work that I do, but I do it in Python.
No, it tends to make sense. Thank you. You as well. I will see you when we didn't. You must be regretting that. Talking with these. That is an amazing sticker. Where did you get this? Yeah. Lower energy because I'm exhausted, but it is decent. Jokes flew pretty well. A little bit of technical stuff. We're using a new so I was testing this on some courses. Tools and demos. That's why we always test dry run the day of. The photography we're fine. Credit where due, those people do know how to write good code. Oh, the conference is now officially over.